We now discuss the solution of a problem from the section three-dimensional geometry, and this question has appeared in the joint entrance examination main held on 28th June 2022 in the second shift. The problem is related to a given line and involving a section formula. The given question is, let the image of the point P with coordinates 1, 2, 3 in the line L, whose equations are given by x minus 6 by 3 is equal to y minus 1 by 2 is equal to z minus 2 by 3 be the point Q. Let R with coordinates alpha, beta, gamma be the point that divides internally the line segment PQ in the ratio 1:3. Then the value of 22 times alpha plus beta plus gamma is equal to. We are given a line L. This is the line L. And it is given the image of the point P with coordinates 1, 2, 3 is Q. And it is further given R, a point R with coordinates alpha, beta, gamma be the point that divides PQ internally in the ratio 1:3. Then required to find the value of 22 times alpha plus beta plus gamma. We now discuss the solution of the problem in detail. We are given capital Q is the image of the point P with coordinates 1, 2, 3 in this line L, x minus 6 by 3 is equal to y minus 1 by 2 is equal to z minus 2 by 3. So this is the line L, and P with coordinates 1, 2, 3, its image in this line is Q. So now let M be the midpoint of PQ, line segment PQ. Naturally, M will lie on L. Right? Since M lies on L and the equation of L is known, the points of M can be obtained by taking these equations and equating to lambda. Then x minus 6 by 3 is equal to 3 lambda plus 6. Similarly, we will get 2 lambda plus 1, 3 lambda plus 2. Those are the coordinates of M for some lambda. The coordinates of M are 3 lambda plus 6, 2 lambda plus 1, 3 lambda plus 2 for some lambda. Agreed. The direction ratios of the PM and L are. The direction ratios of L are 3, 2, 3. PM, P we know the coordinates 1, 2, 3. M we know the coordinates 3 lambda plus 6, 2 lambda plus 1, 3 lambda plus 2. Then the direction ratios are given by 3 lambda plus 6 minus 1, 2 lambda plus 1 minus 2, 3 lambda plus 2 minus 3. So 3 lambda plus 6 minus 1, 3 lambda plus 5, 2 lambda plus 1 minus 2, 2 lambda minus 1, 3 lambda plus 2 minus 3, and that is 3 lambda minus 1. These are the direction ratios of PM, the line PM, and the line L are 3, 2, 3. And we know this PM is perpendicular to L because the PQ, the Q is the image of P in L. Then PM will be perpendicular to L. So PM is perpendicular to L, then their direction ratios, when you will have this one, that is 3 lambda plus 5 multiplied by 3 plus 2 lambda minus 1 multiplied by 2 plus 3 lambda minus 1 multiplied by 3 is equal to 0. This is the property of the perpendicularity between the direction ratios. Now multiply, you will get 3 lambda into 3, 9 lambda plus 4 lambda plus 9 lambda, that is 22 lambda, plus 15 minus 2 minus 3 is equal to 0. That implies 22 lambda is equal to minus 10. That implies lambda is equal to minus 10 by 22, that is minus 5 by lambda. Once the lambda has come, the coordinates of m are known. So take the coordinates of m in lambda and substitute for lambda is equal to minus 5 by 11. In this you substitute. After substitution and simplifying, you will get, it will be 51 by 11, comma 1 by 11, comma 7 by 11. These are the coordinates of m. We continue further for further discussion in the next slide. That's what we have done so far. That's the diagram. What we have. So what is further given to us? Given R with coordinates alpha, beta, gamma is the point that divides the line segment PQ internally in the ratio 1:3. So this is the point R alpha, beta, gamma. This is PR is 1 and RQ is 3. So let us say it is K is to 3K. What we claim is this R is the midpoint of PM. Our claim is R is the midpoint of PM. How do we say that? So let's see in the snippet. So we have PR is to RQ is K is to 3K. Yes, because it is 1:3. So this will imply, and now PM is equal to MQ because it is the Q is the mirror image of P in the line L. Okay, PM is equal to MQ. So PM is written as PR plus RM is equal to MQ. Agreed. We have added RM on both sides. RM on both sides we have added. So PR plus RM is equal to RM plus MQ. So this will imply PR plus 2 times RM is equal to RM. RM plus MQ is RQ. Now PR is K. This will imply K plus 2RM is equal to RQ is 3K. Okay. This will imply 2RM is equal to 2K. RM is equal to K. So thus what we have is PR is K, RM is K, PR is to RM is K is to K. That is 1:1. That means R is the midpoint of PM as we have claimed. So we claimed here R is the midpoint, and that is the logical answering the question. And many of the students will take, yeah, it appears R is the midpoint of PM, or it is R is the midpoint of PM. Without any proof they write, and fortunately it is true, therefore the answer will come. Agreed. So now thus R with coordinates alpha, comma beta, comma gamma is the midpoint of PM. Agreed. Now the coordinates of P are known, the coordinates of M are known, the midpoint formula you use, then alpha, beta, gamma you will obtain. So alpha, beta, gamma is equal to 1 plus 51 by 11 whole by 2, x1 plus x2 by 2, comma y1 plus y2 by 2, z1 plus z2 by 2. So these are the things. Simplify, you will get 62 by 22, comma 23 by 22, comma 40 by 22. So thus now alpha is 62 by 22, beta is 23 by 22, gamma is 40 by 22. So when you add alpha plus beta plus gamma, you add these things, then you will get 125 by 22. And this implies 22 times alpha plus beta plus gamma is 125. That's what exactly is wanted. And in the question, it is asked, well, find the value of 22 times alpha plus beta plus gamma. We have found that it is equal to 125. So it is a numerical question. Only the answer you have to say. The answer to this question is 125. So that is the detailed discussion of the solution of the problem from the section 3-dimensional geometry, and it is definitely easy problem, and I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.